In this segment, we are going to solve the integral from 0 to infinity of x e to negative x. So the first thing to realize is that this requires integration by parts. And integration by parts allows us to split the components of the integral so that we're able to focus on each one of them separately. So integration by parts tells us that for an arbitrary function, u dv, the integral is given by u v minus the integral of v du. All right, and that's equals a function f of x. We're going to say the curly f notation. So to start, we're going to use the acronym LIATE, which stands for logarithm, inverse trig, algebra, trigonometry, trigonometric functions, I should say, and exponential functions, to decide which function should be u and which function should be dv. So this one specifically tells you which function should be u. So as we can see, this is an exponential function, and this is a algebraic function. Therefore, because algebraic functions are above exponential functions, we're going to want to use let u equal x. So we're going to do this below. So I'm going to do this a little bit over here. So let u equal x. And this calls for a du, right? So we're going to need to differentiate this too. Du equals dx. And now, since u is x, then dv must be e to negative x. So that v is negative e to negative x, right? And so now we can simply plug all these components in and evaluate from 0 to infinity. So I should make sure to put that notation in there. We're going to get, first, we know u is x, so we're going to get f of x is u, so x times v, which is negative e to negative x. This is evaluated from 0 to infinity, minus the integral from 0 to infinity of negative e to negative x times du, which is dx. So what's going to happen here is I want to focus on this integral first. So in this integral, when we do u sub, this is going to turn into negative du equals dx. So we're going to basically pull out a negative sign. So, and then we need to also take into account this negative sign here and this negative sign here. So let's do some simplifying. So f of x is negative x e to negative x, evaluated from 0 to infinity. And furthermore, we have that this as well, the integral. So I'm going to pull out the negative sign, so I'm going to get a positive. And when we pull out the negative, this negative right here, it's going to create a negative. So these two pull out to create a positive, and then this one right here pulls out to create the negative sign. So I'm going to go ahead and erase this here. And then we know the integral of e to the x is just e to the x. So I'm going to write that down. So 0 to infinity of e to negative x. Okay, so we can go ahead and combine these two expressions because they're valued from the same limit. So we can say f of x is negative x e to negative x minus e to negative x, evaluated from 0 to infinity, right? An important thing to know is that we need to change this into limit notation because you can't exactly get to, like, infinity isn't a finite constant. It's, you just approach infinity. It's only possible to approach infinity, so we have to use limit notation. So if we zoom into the negative x e to the negative x portion, we're actually going to get a bit of an undeterminate solution. So what we should do in this case is we should say, let's pull out an e to negative x so that we get more clarity on what is happening here. E to negative x, and we're going to pull out, we're going to end up with a negative x minus 1, right? So now I'm going to evaluate this. And so we know this can be rewritten as negative x minus 1 divided by e to the x. We're just going to put this negative power on the denominator. So I'm going to get negative x minus 1 divided by e to the x. And then we're going to have the same notation. Let me rewrite this real quick. Limit as b goes to infinity from b to 0. Okay, so what we need to understand is this exponential term is going to grow much faster than this linear term. So we can basically say that by that definition, that e to the x is going to grow way faster than that. It's going to approach 0. So let me rewrite this real quick, and I'm going to get limit as b goes to infinity, and I'm going to plug in the b. So we already made the argument that limit as b goes to infinity of negative x minus 1 divided by e to the x is 0, because this term grows very fast. And so it's going to beat out the negative x and minus 1 term. So essentially, we're going to get left with a 0. And then we're going to subtract. Now we're going to evaluate at 0. And so I'm going to get negative 0 minus 1 divided by e to the 0. Now e to the 0 is just 1. And we essentially have negative 1 divided by 1, because the 0 is negligible. And then we have negative 1 over 1, and then we have a subtraction symbol. So that whole thing just goes to 1. Therefore, the limit, the final answer is that the integral from 0 to infinity of e to negative x times x dx equals 1. And that is the final solution.